present about TCP and IP in Wireshark. Firstly about TCP in question 1. What is the sequence number of the TCP SYN segment that is used to initiate the TCP connection between the client computer and Gaia CS UMS Edu? What is it in the segment that identifies the segment as a SYN segment? Okay, first we pick a frame number 1 and pick a transmission contour to get a sequence number. Sequence number TCP, the sequence number of the TCP SYN segment is 0, and the SYN flag is set to number 1, so we get from this. Question number 2. What is the sequence number of the SYN X segment sent by Gaia CS UMS Edu to the client computer in reply to the SYN? What is the value of the acknowledgement field in the SYN X segment? How did Gaia CS UMS Edu determine that value? What is it in the segment that identifies the segment as a SYN X segment? Okay, then we pick frame number 2 and also pick transmission control. So we get this as sequence number is 0 and acknowledgement number is 1 and the SYN set is 1. Question number 3. What is the sequence number of the TCP segment contain the HTTP post comment? Note that in order to find the post comment, you need to dig into the packet content field at the bottom of the Wireshark window, looking for a segment with a post within its data field. The sequence number of the TCP segment containing the HTTP post comment is 1. So we get is inward post. So when we got the sequence number 1. Question number 4. Consider the TCP connection. 4a. What are the sequence number of the first 6 segments in the TCP connection? So in Wireshark, we must find the TCP segment of a resemble PDU. So we get this and this. So we check in a sequence equal 1, sequence equal 566, sequence in 2026, sequence 3486, sequence equal 4946, sequence equal 6406. So this is a sequence number in a segment 1, 2, 3, 4, 5, 6. So packet number 4, 5, 7, 8, 10, 11. The packet number we see in this below. B. At what time was each segment sent? So time segment we find in this section time. So the packet number 4 time sent is 0.026477. And the graph is we'll get in this.
Okay, next I want to tell you about the Wireshark Lab for the IP. Question number 1. Select the first ICMP echo request message sent by your computer and expand the Internet Protocol part of the packet in the packet detail window. Okay, this is the view. So the question is, what is the IP address of your computer? Okay, we can see in the picture that this is the IP address 192.168.1.102. Okay. Question number 2 is within the IP packet header. What is the value in the upper layer protocol field? Okay, the answer is the upper layer protocol value is ICMP number 1. Okay, in the picture we can see that the upper layer for ICMP is 1. This is the ICMP number 1. Number 3. How many bytes are in the IP header? How many bytes are in the payload of the IP datagram? Explain how you determine the number of payload bytes. Okay, let me see in this picture. They tell us that we can get the IP header is 20 byte. It's from here. That picture, right? Question number 4. Has this IP datagram been fragmented? Explain how you determine whether or not the datagram has been fragmented. Okay, in this picture they tell them don't fragment or not set. So the discussion is there is no data fragmented. A fragment offset equal to 0. So mean this is the fragment offset, and more fragment is not set. Then question number 5. Which field in the IP datagram always change from one datagram to the next within this series of ICMP messages sent by your computer? So the answer is identification. Time to live and header checksum always change. Question number 6. Which fields stay constant? Which of the field must stay constant? Which field must change? Okay, then why? The field that stay constant across the IP datagram are version, since we are using IPv4 for all packet. Header length, since this ICMP packet. For the source IP, since we are sending from the same source. Destination IP, since we are sending to the same desk. Differentiated service, since all packets are ICMP, they use the same type of service class. And the upper layer protocol, since this ICMP packet. Okay, that field that must stay constant are right. Version, header length, source IP, destination IP, differentiated, upper layer protocol. Alright. Okay, question number 7. They tell us to describe the pattern you see in the value in the identification field of the IP datagram. Okay, how to describe this pattern? Okay, for the first one, we click the first one and click the internet protocol version. After that, we get the identification. Okay, the highlight one. Okay, no, the color of the highlight is red. Okay, at segment 8, the identification is 0 times 32D0. Okay, we click like the pass, the internet protocol version, and we also get the identification, but the answer is 0 times 32D1. First one is D0 and the second one is D2. Right. Number 8. What is the value in the identification field and the TTL field? Okay. The TTL field is the time to live. Okay. Time to live. The identification 0 times 32 D0. We click that and we get the time to live is 1. Okay, number 9. Do this value remain unchanged for all of the ICMP TTL exceeded replies sent to your computer by the nearest first hop router Y? Okay. Like the picture tell us that we get for the first row 1 is TTL equal 1. Okay, the answer is the identification field changed for all the ICMP TTL exceeded replies because the identification field is unique value. When two or more IP datagrams have the same identification value, then it means that these IP datagrams are fragments of a single large IP datagram. The TTL field remains unchanged because the TTL for the first hop row is always the same. Okay, let me see. Alright. Fragmentation. So the packet is listening according to time again by clicking on the time columns. Let's go to the next question. Number 10. Find the first ICMP echo request message that was sent by your computer after you changed the packet size in ping plotter to be 2000. How has that message been fragmented across more than one IP datagram? Yes, the answer is yes, because this packet has been fragmented across more than one IP datagram. Okay, go to the question 11. Print out the first fragment of the fragmented IP datagram. What information in the IP header indicated that the datagram be fragmented? Okay, what information in the IP header indicate whether there is the first fragment versus a later fragment? How long? Okay, we click the first one, the blue color highlight, and the red one. After we click this, we get the data. Okay, data is 1480 byte. The flag bit for more fragment is set, so indicating that the datagram has been fragmented. Since the fragment of set is 0, we know that this is the first fragment. Okay, this is the first fragment. Okay, 1 for first. The first datagram has total length of 1480 including the header. So, like we see in the picture, we can get the information we discussed about. Question number 12. Print out the second fragment of the fragmented IP diagram. What information in the IP header indicate that this is not the first datagram fragment? The most fragment? How can you tell? Okay. We click the highlight. For the blue color. Then we click the red one. So we can get the answer by looking at the last one, the blue color of highlight. So we can tell that this is not the first fragment, since the fragment offset is 1480. It is the last fragment, since the more fragment flag is not set. The first one is 1480 byte. The second one we get is 4 to 8 byte. Question number 13. What field change in the IP header between the first and second fragment? The IP header field that change between the fragment are total length, flex, fragment, offset, and checksum. The IP header field that change between the fragment are total length, flex, fragment, offset, and checksum. Okay, now find the first ICMP echo request message that was sent by your computer after you changed the packet size in ping plotter to be 3500. Okay, question number 14. How many fragments we created from the original datagram? Okay, for the question how many fragments we create from the original diagram, and the picture tell that the byte is all the same, 1480. Okay. After switching to 3500, you can get 3 packets created from the original datagram. Okay, that for the last question, 15. What field change in the IP header among the fragments? The IP header field that change between all of the packets are fragment offset and checksum. Between the first 2 packets and the last packet, we see a change in total length and also in the flags. The first 2 packets have a total length of 1500, like we see in the picture. With the more fragment, bit set to 1, and the last packet has a total length of 545 bytes, which the more fragment byte set to 0. Okay, that's all. Thank you for today.